Thanks everyone for coming to our talk here. Thanks to Peter Pivotal for arranging us. We are going to cover today about how to have the REST services with RabbitMQ, Spring Integration, and Node.JS. We presented last year in Santa Clara. We kind of covered a lot of the stuff on how we used RabbitMQ and Spring Integration. The focus was on taking existing services, putting it onto RabbitMQ, why we had to do it, how does Spring Integration play a role, and that's what we covered. So this year, our focus is more towards taking REST services. How are we able to leverage? Some other part is already running, and we're very successful in doing this for our company. We wanted to kind of share some of what we did, our experience, and share that with the team here. Before we get started, my name is Durai, Arasan. I run the architecture team. In our company, our responsibility is to kind of bring the new technologies, build frameworks and support, and make that used for all the ETrade.com website. And anything within that, our technology, our team provides that support. And we build a lot of the frameworks. Sometimes we bring off-the-shelf products. Many times we try to take the best components available out there and bring them, integrate them for our needs. And this is one of that effort. We wanted to kind of share that with you. And
I'm Monish. I work in the architecture team too at ETrade, and we build great frameworks. Today we're going to talk about Spring Integration and Node.js.
So the way we structured this talk, we wanted to give the background. I think, I don't know, how many of you attended last year's talk, the one we gave? Is anyone? Okay. I did. So that's good. So we want to give a little bit of background on how we did it. We're not going to get into a lot of information, what we presented, but I think it will be good to kind of give that context, how we use this product for some of our need, and then give a demo about that. So we wanted to kind of make some talk and then get into the demo. This is a Spring conference, so we don't want to kind of just do only the presentation part. I think you'll be not interested in that. So we'll be showing the code. We'll walk through that and run some of this example. And then the second half of that, we'll dive more into how Node plays a role on what we were able to achieve to run some complex systems. How does that play? Why do we need it? And then we'll show some demo on how that works. So it'll be interesting to kind of see both of that talk in this one, okay? In terms of the background on what we do here, I think a couple of things is very important for us and to run our site and provide the service to our customers. And the topmost, I think, in that is the speed. I think we really want to execute the trade. It involves money, and the time is critical for our business. And anything we want to run needs to be extremely fast, and we also guarantee our service. There are legal obligations. So speed is critical, and the technologies we pick requires the speed. I think that's very important. So that's one of the core reasons we look at finding the best components out there and bringing that to ETrade and then integrating that with it. So speed is critical. And the other thing we learned over the period is that we've been doing this service-oriented architecture for a while, and we've grown from building with C-based services, we went on to Java, and there are a lot of other languages keep coming, and it's getting really popular. So we want to explore the options of providing that with the support for doing multiple different services using different languages. The reason is that you pick the tool right for the job you need it. Since we have a huge number of services, we also need to making sure that they are all able to run it simultaneously, be able to run with the different payloads and different protocols, because we have a different kind of clients running on our backend infrastructure. And when you have multiple services running, a fault isolation comes into play. We need to making sure that one doesn't impact another. We want to be able to keep that running. And we want to be able to making sure that the reporting and some of that features, I think you come bundled with some products, sometimes it's not adequate enough for the needs. So we want to be able to customize it, have that ability to do that, everything. And also, there are a large number of services and legacy services that are always there. And as you build a new platform, a new framework, a new business functionality, there's going to be mixed of new. So you ought to always live with old, and then when you have an enterprise, live with old and new, and be able to support that with this framework, which we are using it in our ETrade. So let me just show you the architecture in a high level, how we kind of formed it. We use the RabbitMQ. RabbitMQ is the core of what we actually use it. And then we have different language-based services that are running. So there are some of them are legacy services. Some of them are brand new we're building. This model allows us to kind of expand and build, develop services based on the languages, the type you want to build, and plug it into the system. So as far as the client is concerned, they are all connecting with one message, one way of communicating into the service. They are not able to really, they don't have to worry about whether it is running in a C or a Python or maybe Groovy, whatever you like to write, you can do that because the messaging layer abstract that out for us. And we also, like we are building it here, we are able to put in with the admin and monitoring, the process manager. And the other cool things with RabbitMQ is that it allows us, with some extensions, you can actually make use of an alternate exchange and the DLX, which is another exchange that allows us to kind of route the calls to different based queues, as well as it can also allows us to do message handling, whether if this message is stuck on the queue for a long time, how do you kind of dequeue them, send the proper response back. All that is possible with DLX as well. So in a high level, this is the architecture we put together. We'll kind of show a little more into it. Before we get on to it, I wanted to kind of talk briefly about why we choose queues. And I think it's kind of, you must be wondering, there are ways people have done it, and what is the reason for using something like this than to picking up a traditional, a REST container or a SOAP container. So for us, I think in the single queue model really doesn't work very well, and it's a mercy of the previous request. So if you have everything queued up in one, and that is what typically happens in a typical container with HTTP base, there are maybe an option, but you really want to avoid that by not going into a single queue model. And the other important thing to pay attention is the quality of service. So if you have calls going through it, and if there are multiple endpoints which are running it, and each endpoint, and even within the service itself, a single type of service can actually perform differently based on the request that's coming in. So you want to be able to use the traffic shaping, some of the functionality built into RabbitMQ, and that really provides us a way for doing a quality of service. And sometimes we see these errors like 503 server too busy. If there are too many requests coming in, the server can't even handle it, and it gets kind of a weird errors back. And it's sometimes hard for the client to understand what the reason for it. So we want to able to have a proper response. And anytime, even if the server is too busy, be able to kind of route the call in error handling, provide a proper structured response back is important for us. And looking at the pending requests, if there are, again, a lot of requests queued up for some reason, either your consumer is busy, how do you monitor them? How do you kind of peek into it and then have some actions taken on? If there is some issues, how do you route them into some kind of an error queue and then provide that response back? That is possible when you have a queue-based system. And administration of all these consumers. And if there are load happening, like bringing up a new set of consumers on the fly, it works out of the box. There is no need to worry about it. So these are some of the reasons. There are a lot of other reasons. I think there are some good reasons where we feel that doing this model compared to the other works very well for our need and be able to kind of scale to the demand of the number of calls we're able to do. With respect to queues, I think there are a lot of queue-based system messages available, message servers. We chose RabbitMQ for some of these reasons. I think Like I said in the beginning, we have large number of services and there are a lot of processes running, and that needs to be able to connect into a messaging server. Some messaging server has limitations on how it is working, how it's able to connect, and you need to have a connection pools and all that. And we also want to making sure that, like you saw in the diagram, there are a number of different languages we wanted to promote, have a way to connect so that you can write services in various different languages. So RabbitMQ actually provides a way for you to do that, and it's an AMQP based system. There are other solutions, and when it comes to AMQP, there are a lot of bindings available. I think the last time I checked, probably about 12 to 15 different bindings are available in different languages, and it works very well with Spring. We are a big Spring shop. We use a lot of Spring framework, and for us, integrating with the messaging server that comes built-in support is awesome. And some of the extensions for the enterprise provided by RabbitMQ, that's also pretty neat. And we're able to kind of leverage the alternate exchange where you can actually decouple your client from how the queuing systems work and how it's configured. You don't have to really worry about that at all. And in terms of all the properties that are available, you can set in the queue for the message, how it is getting routed, if there is a delay in getting processed, that's built into RabbitMQ extensions that are extensions out of the AMQP. So, and the security is a big thing for us. It has a built-in security support, and it has a pluggable models where you can add your own additional security layers if you like. That's also supported. And I think some of this, again, is critical. Some of you may be already using it, and it really worked very well for us. So that's on the messaging side. So moving on, wanted to kind of briefly touch on how Spring Integration plays a role. We use Spring Integration for connecting with our services. We write Java services, and we want to leverage all the work already been done on the world of JAX-RS, JAX-RS. I think everybody in the Java world might have already written services. You know how to do it. You know how to deploy them, how to run them, test them. Doing all that work is already done. Now that we're building with the RabbitMQ, and we're changing a lot of underlying way how these services are executed and the calls are routed, we also need to making sure that we don't want to invent something totally new of the different programming pattern, because everybody's familiar with the way how to write in Java with JAX-RS. There are already tools available, how to do that, how to debug them. We want to leverage that. At the same time, we wanted to kind of integrate it with Spring Integration, where we can do all the cool things that's available in Spring Integration. So all the the EIP patterns that are built into it really makes us to do in-JVM orchestration. And it helps us to do many things. And we wanted to do that. At the same time, we wanted to be able to do a service activator that are JAX-RS and JAX-RS compliant. And that's what we able to do here. We actually built a custom service activator, and we also built custom gateways and transformers that can do the bridge between how the Spring Integration works with respect to its own orchestration layer and how the Java services that are written in JAX-RS or JAX-RS, how can they be connected? So we use something called a CXF bridge. That's something we have written ourselves and using it. So CXF works great, and it runs with a servlet, and it can do its own thing if you want to run it on any servlet container. But since we are doing with the queue-based system, we wanted to leverage the queues. We want to be able to leverage the Spring orchestration layer. And then at the same time, we wanted to be able to use the JAX-RS and JAX-RS services. So we built this thing called integration conversion service for CXF message, where instead of routing calls through the servlet, because there is no servlet running in this pin, and the calls are coming through the Spring Integration, it uses the CXF destination and invokes the actual service that are written for the CXF. So we're using some of the CXF engine, but we are avoiding the initial servlet related calls. We have the custom transport built in. We can directly execute any CXF service that's written with the JAX-RS and JAX-RS. That's pretty cool and be able to kind of run it with that. It kind of handles your errors and all the use cases which you generally find it in the endpoint, and that translated back into the Spring integration with the AMQP message. So that's what you're able to do with the integration. And in terms of the REST, I think you'll be wondering, like, REST is built with, HTTP in mind. How does that map into it? So we map that into AMQP with a basic GET and a basic publish. That pretty much takes care of how we map our work. And in terms of the JAX-RS on AMQP itself, if you look at it, JAX-RS is not, it's primarily relying on a lot of the HTTP. Is that really a bug or a feature? We wonder sometimes, really you want to kind of tie it up to an HTTP protocol. In our case, we think that, not necessarily. You don't have to do that just with HTTP. Make use of the infrastructure, make use of the ecosystem, all the patterns that are available, but use a queue-based system like AMQP and RabbitMQ, and that's what we are able to do that. Here is an example you all will be very familiar with. This is a very simple echo service, it's doing the post and get, and there is no difference. This is a very straightforward JAX-RS interface that you may drop it onto any CXF or any other container, and we are able to run the same thing with the work we have done with Spring Integration and RabbitMQ as well. Here's an example of how you would configure them in the Spring config. So if you see here, you have the JAX-RS server configured. There is the echo payload, the interface which was defined earlier. Here's the implementation of that. The only difference you see here is that this with the AMQP protocol. So you would do, instead of another HTTP endpoint, you are here using an AMQP endpoint. So that's the only difference you would see in terms of the configuration. So when you get into the demo, you will see more details on how this is going to work. In terms of the Spring configuration, the Spring integration, the gateway, and namespace, so we have created our own namespace, which kind of allows us to simplify and kind of have the whole Spring notion of convention over configuration. We try to follow that model, cut down a lot of the extra configuration, and provide a custom gateway with a custom namespace, and be able to define that service interface and the endpoint. And once we have this, Spring integration knows what is the service activator to call, and it does all that work behind the scene with this custom interface, be able to get onto it and execute the service and get the result back. So with that, I'm going to kind of get into the demo. I'll have Monish get into the demo, so you'll be able to see how the RabbitMQ works with the Spring integration, some of the JAX-RS service, which we were showing earlier, be able to see it in action, and then we'll continue on to the next segment.
Thank you. Thank you, Durai. Is everyone able to hear me? Okay. How many of us here are architects? Show of hands, please. Okay, and all of us call ourselves architects. Okay, how many of us are business logic developers? All right. So these are the guys who really do the work, right? So for a living. So the idea is to make the business logic developers go home early, right? And that's the basic idea of doing anything with architecture. So some of the things that he showed in the slide. Now I'm going to get to the nitty-gritties, right? The dirty nitty-gritties. The propaganda is over. Okay, so let me just make this big. This is our most familiar interface, JAX-RS interface. As you see, you have a path variable, then you have payload, whatever, it's a path again, consumes, produces these media types, and has some object here. What does that beast look like? Well, as it happens, that beast is actually a JAX-B object, right? So this is good. This is going to set us up for what we are going to see. So before we do anything else, let's run the demo. OK, so if I prayed to the right gods today, I would get this up and running. So as you see, I'm going to run a JAX-RS service, right, that is defined in this way. This was the JAX-RS server, as you all know. And the only difference here lies in the address. The address is AMQP. So what's happening here is we change the transport underneath. CXF basically supports HTTP out of the box, and it has various other bindings for JMS. But now we change the transport to use AMQP. The rest of the stuff more or less remains the same. OK, that's the key. So one can wonder how a messaging system can handle something like a JAX-RS client. Well, there's a lot to it, but let's just run through the demo. Hopefully my service is up, yep, and then I will just run the client. So I'm going to just do that. I'm going to have some fun doing this. And hopefully everything works. Oops, OK, that's good. So I got echo payload up and running. I don't know how many of you can see. There is the result. OK, this is all good. What happens really is on RabbitMQ, the queue comes up, and the queue looks somewhat like this. So how many of you are familiar with RabbitMQ routing keys and exchanges? OK. So as you see here, what's happened is the routing key itself has this pattern. It has this coordinate for JAX-RS, right? But is this good enough for all clients? You see, when you annotate a JAX-RS service, let's go back to our JAX-RS service. When you annotate a JAX-RS service, you're basically annotating it with a lot of coordinates. Is this good enough for us to basically say that we have built a JAX-RS service? It's all good when we talk about JAX-RS clients from Java clients, right? OK. The problems could be we invoke this using XML. How many of you have invoked JAX-RS services behind JSON? OK. So one of the things that you have to do, if you're familiar with the JSON payload world, is that you have to do something like this. You have to have some sort of a JSON namespace provider or a JAXB provider. Most platform teams in various companies do a lot in order to get this going. And then you have to come up with this payload that's going to have the static configuration. So in this case, our JSON payload is going to look something like this. Just bring it. Something like this. OK? Well, this was not the first attempt. If you just look at CXF out of the box, it supports something like this. So this is called the jettison format for JSON payloads. Because what's happening is on a JAX-RS service, you define a JAXB binding, and that JAXB binding has namespaces and prefixes and all sorts of things. So this is your jettison binding. You also have an option of going badgerfish binding, right? And you would have something like this. And then you have the option of providing your own JSON provider, and that would look something like this. OK? So it's all good. This is going to be our precursor to what's going to come. So back to the demo, back to the presentation. So what we did right now, we put a JAX-RS service listening on an AMQP inbound gateway, right? And we sort of said, OK, we called it from a JAX-RS client. It called using XML. Great, but no great shakes. What happens is, in the web world, not only do internal clients, but also sometimes one day an external client may want to call this service, especially with rich client interfaces. You have Angular, you have all kinds of rich client interfaces. So one day you might want to expose these services to clients outside the Java world. If you're using RPC libraries of your own, you can always invoke this using some CXF tricks or some transport tricks. But now you really want this transport to be in the HTTP world. So HTTP web services, that's what you want, right? Yes, it's somewhat of an anomaly here, but our choice is Node.js. There are several reasons for this. So what is Node.js? Node.js is the reason for its living. The only reason that it lives is because it wants to serve files to HTTP servers, HTTP clients on an HTTP server. So all it does is take a file and serve it out. So it's a very lightweight deployment paradigm. So what you want to do with it is minimal transformations. And those transformations are a bit tricky. We'll get into it. You want to probably do some sort of a protocol transformation. And it has this asynchronous support out of the box. So it is basically built for JavaScript. JavaScript has these callback mechanisms. And if you're using it for the right purpose, then you have hit the nail on the head. So it's not, you want to make simple things simple and complex things possible. How does it fit into our architecture? So the way it works is, for our internal clients, there are some internal clients too, believe it or not, that only talk HTTP, right? And you want these transformations to happen real quick. All Node has to do is to do some sort of a protocol transformation. So what we are talking about, we build this JAX-RS service, and this JAX-RS service now wants to get hit by an HTTP client. Here's the problem. You don't have any of those HTTP headers. You don't have any of those HTTP methods that you can make use of. You don't have any of those things in the AMQP world. We know that we can put a JAX-RS service behind a JMS queue. But JMS, by its very nature, is Java messaging service. But here what we have is a web client, a client that talks to an HTTP server, and there's the AMQP queue. How does it invoke the AMQP service? OK, so we come back to the fact that AMQP clients only know about exchanges and routing keys. And they are backed by queues and a binding key, right? Now, so what Node.js has to do is it has to use this binding key from RabbitMQ. And fortunately for all of us, we don't have to do any sort of big pattern matching. There's an RFC standard called 6570 that allows us to use an URL template library in order to match the JAX-RS horrendous resources right back into our clients. And what we do is a little nifty HTTP header mapping. I think I pressed the wrong key. OK. So here's what it says in a diagram. So essentially, you have Node.js. You have AMQP headers. And you have HTTP GET calls or POST calls. And then they need to be mapped to a service call, right? So basically, you take these AMQP HTTP headers, translate it into AMQP headers, stuff the stuff so that CXF understands it, so that you want the CXF engine to run. And then you've got to get your JAX-RS service to be invoked, right? So at this point, actually, I'll do a demo, and then we'll go to this part of Node.js. So at this point, let's do a demo of calling our JAX-RS service from curl. So we have this JAX-RS service running here. And let's call this. Before that, of course, I have to start. Sorry about the fonts. Let me clear this. So let's start the Node.js service here. OK, so what it has done is Node.js has started. It is subscribing for reply queues on AMQP, on RabbitMQ. And it is listening for the port 19091. OK? And here, what we are going to do is we're going to call a curl request. And these are the different, can you see? OK. Is. So we're going to call a curl request with various in various ways. The first one is going to be XML. No braid shakes. We got XML. The thing to realize is we call this on 1901, right? So if you look at the curl request, it's on 190.1.901 port. And content type is application XML. And it says HTTP 200 OK. OK, that's magic. Another thing that we're going to, and then you have some AMQP headers coming back. That's because an AMQP service got called, which is right here. And you're going to see the horrendous payloads that it can give back. But now let's call it with JSON. OK, so just simple JSON request. So what's the payload for this? The payload for this looks somewhat like this. Remember, we put an NS1 namespace. So we take this, we make it my favorite number, 42. In fact, let's make it 142, just for, and then let's call this. And there you go, that's 142 payload right back. But we still have to take care of the namespace being right. OK, so that's going to be my segue to the next part of Node.js, how Node.js can be used. OK, this is good. How about, let's see, something like this. So remember, we have a queue there in RabbitMQ that has a routing key that says get something. And it has this binding type with this JAX-RS kind of curly brackets, right? OK, so now will it match my pattern? Let's make it, I don't know. What's the good number for today? 120. All right, let's see whether it matches 120. And that should be 120 long. So the way I do that, you can do a simple check. You go into Node.js and do length. So you can play around with this. 119, maybe I missed one somewhere. OK, let's do it again. There. So earlier, I had missed something. OK, so this is all very good. We got JAX-RS working behind curl, and there is this AMQP. So what we have demoed here is the presentation of where what we're doing is we're getting a client that doesn't know anything about AMQP queues. We go through HTTP. We start our Node.js server. And it is able to call all the JAX-RS patterns, including query parameters, including header context, which are all path parameters. So you can imagine all the different resource allocations that you can do in a JAX-RS interface. You're able to do that with a simple node transformer. Back to the presentation, because we'll show some more capabilities of Node, right? So now we have added, now the other thing that maybe you want to do is not just call JAX-RS services from behind AMQP that provides us with the queuing mechanisms and robust features, monitoring features, but you also want to probably make use of Node's JavaScript way of function callbacks in order to make APIs, right? One of the reasons being you may want to have internal service routes. You may want to have vanity URLs. There are HTTP attributes that you are dealing with in your Apache web service, Tomcat service. So all of these things you should be able to handle with Node. So Node is really good for doing this sort of work. It's really good to do protocol conversions, HTTP to AMQP. It's really good to do payload conversions. You have to be very careful when you do payload conversions. It has to be done in an asynchronous way. It's good to define declarative routes. It's also good to do aggregation for you. How many of you have written concurrent composite services and clients in Java? OK, it's painful, to say the least. And it's very difficult to get right. OK, the callback and the correlations, especially with asynchronous I/O, can get really hairy. It allows us to follow the do not repeat yourself paradigm, which is essentially avoid boilerplate code. So Node, out of the box, that is, we are talking about 0, 1, 0, 2, 0, and we have certain libraries that you can make use of right out of the box. You don't have to go into composing your services with executor, service, and threads, and multiple threads, and concurrency. There are paradigms, there are libraries that are available out of the box in Node that allows us to parallelize your services, parallelize your clients, do aggregation, do series of calls, right? And we'll see some demos of how you can front-end them. So it's good for composing flows. And this is just the tip of the iceberg. Because when we come to 0, 1, 1, 1, 3, you have promises, generators, and yields right in the V8 engine of Node. Okay? So Node is built on V8. How many of you are familiar with Node? OK. All right. There's a lot of hands, actually. So the other uses that we do is we expose services. We expose services as APIs. It can be used for testing them. And it can be used to mock the services. We can also do benchmarks. So now we're going to do some demos for this. OK. So back to our world, demo world here. OK, we got this guy. I'm going to stop the REST service. This first demo is going to be on, I have a legacy SOAP service working. And I want to make an API, a REST API, right? And can everyone in the back see it, or do I have to make it bigger? OK. So I have a SOAP service working. I'm going to run the SOAP service. And I want to call it with, it's the same familiar SOAP service which we saw earlier with echo payload as the binding. And now I want to call it asynchronously. And I have one more thing that I want to do. I don't want to put namespaces. I don't want to put prefixes. I don't want to put anything. I just want something like this. I just want something like a JSON payload. And I don't even know what are the required properties for this SOAP service. Okay? So here's what I have. Let's see whether we can call this. Behind AMQP. So if you see now, let's look at our queues. So we know that we are not doing anything else. Yeah, there it is. It's not a REST service. It's a SOAP service. And it doesn't have any of the REST-y stuff. But I'm going to now invoke it. It's a SOAP legacy service, and I'm going to invoke it using a REST API. Okay? So let's see that. Let's see how successful we can be in that. So let's see, cat, go post. OK, there it is. OK, seems to work. So what does it take to do something like this? Let's change this thing, just to know that we're not doing anything. Let's change it to the number 42, the meaning of life. There it is. And we can play and do this all day long. But so the idea is, what does it take to do something like this with Node.js? OK, so let's just look at a toy program. So OK, this is the AMQP API. Sorry. So what does it take to do something like this is we go into routes. OK, so if you were just writing an AMQP, an API like this, you would be writing something similar to this. Like if you were just using Node out of the box, raw Node, you'd be writing something like this. You just transform the APIs, and then you use certain libraries like SOAP and AMQP, and you're able to use your API, change it to whatever you want. So for example, here, what we're going to do is we don't even want this. We want to run an API. So we want to run a SOAP service, good old SOAP service, and we want to have an API that has our keys. It doesn't know anything about payload size. It doesn't know anything about request padding. We want to have our own keys. We want to define them, right? So let's just start a CXF service, a plain old CXF service. OK, that's here. Let's go here. OK. There is something already using this address. It's probably because I'm running it. Yeah, right here. And here, what I'm going to start is a Node.js server. I don't know why it keeps disappearing. OK, it's better. And now I have something like this. So I started a CXF service here, right? I started a REST service here, and I've got something right out of the box. It looks something like this. Okay. Has anyone used something called enunciate for exposing JAX-RS or JAX-WS services as REST API? Has anyone used enunciate? Yeah. And Swagger, RAML. All right. So this is more or less use of Swagger. And people who are familiar with it, we can just try this out and see, OK, it all works. So essentially, we have just put this JAX-WS service, and we're calling it from a Node.js front end. Okay. So what does it take to do this? So what it takes to do this is really simple. OK, this cannot be seen. So if you want to define your own APIs, let's say the internal API takes all these different keys, right? So there's this submit echo payload. Let me explain a bit about this before we get into this. So basically, we create something like a REST API from a SOAP service using a SOAP connector. We could actually use the WSDL, or you could invoke the WSDL remotely. So that's what is happening here. It makes our data source for us. So either you could give the WSDL file like this, or you could invoke the WSDL service with a question mark, that URL. And then it has an emitter called connected. You have to wait for the emitter to give a call back to us, an event called connected. And then it creates this model, this eco-service model. We write our API with familiar Node paradigm. So you have, let's say I define an API called size. So that's the API that I want to expose to the world. I now have this eco-service model. Then I can invoke the methods within the eco-service model, which is this method called submit eco payload. It's almost like a dynamic proxy. Those who are familiar with CXF, they're familiar with dynamic proxies. I can give parameters that are default. So imagine, this is, of course, a toy program, right? But imagine if your service has to take like an order service. An order service only takes 5 fields, for example, from the user. And when you place an order, it has to call multitude of services. It has to build those services, and then call those services, and then give back maybe an aggregated result back to the user, right? So you may have like 5 fields, 3 fields, 2 fields, depending on the customer tier that is coming in. You may have certain security things that you want to hide from your ultimate client. So you have some default variables. But 1 or 2 parameters you want to expose to the clients, and that is like, let's say, your size. And then you just want to get the result back. OK, what if I wanted to, let's say, do something more? Maybe I want to define size and sleep. OK, so let's do that. I'm going to end this here. And see how long it takes for us to expose this. OK, that should be it. So note, I haven't rerun the service. I'm just going to restart my Node server. And let's see if I've, again, prayed to the right gods. There we go. Some things to notice is, OK, I got a post here, right? And I'll say sleep for a second, I think, or let's say sleep for 2 seconds, right? Oh, one thing. So everybody who's familiar with Swagger and Angular knows we can do some cool stuff like this. So if you don't put the required parameters, we're able to check that. So 42. Try it out. We had to wait 2 seconds there. It's 2 seconds, and that's 42. OK. So we saw how quickly we are able to build a front-end client. So how about some gets? So let's do a get. Let's do a simple get here. Spring World. Do this. And that's it. Go here. And I never restarted the, now, another thing is, look at this. It's just crazy unreadable. There is just prefixes, suffixes. If people who are working with these prefixes, there's this thing that happens to us almost on an everyday basis. This is not the right prefix. The internal prefixes are different, not bound. You don't have to deal with all that. I just changed my interface. It uses JSON as the request, and it gives back JSON as the response. I didn't have to deal with this. I didn't have to deal with a JSON provider. I didn't have to deal with a JAX-B provider. I didn't have to think about serialization, deserialization. A lot of that stuff happens under the covers in Node. So there's a lot going on there, which we hide conveniently. So what makes it a get or a post is this verb here. So as part of this, let me make this a get. Let's see whether this is as simple as what I'm saying. Also, let's make this not required. Make it false, make this get, and we have another get here. OK. Let's go do this. Yeah, and that's because Angular picks it up, but I have to restart my service. Let's see, payload sleep, payload sleep. OK, that's payload sleep, verb is get. And OK, let's restart this service. There we go. So payload sleep has now become get, and the hello spring world is also now out there, and we have a get. Let's do this. Let's put a size. Let's say 320. Let's go try it out. We got 320, and it didn't tell us to put the required field here. For this, it's just no parameters, default parameter. And at the end, it is calling all these XMLs, the SOAP services behind. OK? The number of times that we have invoked it. OK, this is all good. Well, how about like if you have services that you need to call parallelly, concurrently? You have all these clients. They're calling these services concurrently. You want to do some kind of aggregation and return some result back. OK, so you have this library in Node, which is called async library. And we'll make a front end for it. So the async library has got this paradigm. It's called async.parallel. And this is just a toy. But you can imagine, you don't have to, there are various paradigms in it. There's async series. There is async waterfall. There is async for each. they all work on different sets of collections. In this case, all this is illustrating is a certain way of calling maybe the same service, in this case it's one service, or different services which may be called parallelly, totally mutually exclusive. If there are any errors that each of these services send back, then those errors are caught as part of the callback mechanism in Node.js by default. You have a function, and the first thing that you do in Node.js is function, error, result, and sometimes callback. In fact, function, error, and callback. So you always have to think about what happens when you invoke something asynchronously. You always have to think about what happens when there is an error. What sort of errors do you have to deal with? You cannot escape that in the Node world, and that's a good thing. So here, what I'm doing is I'm calling the same service multiple times. The first time with 42, the next time with payload 100, next time 23, maybe payload size 1. I am, just for the sake of the demo, because the errors are kind of, they have to be dealt with, I'm having my callback with null, right? And then usually what I would do is have an aggregated result. For example, this result will not be the array of results that is coming back from calling all these services. It'll be like, I called these services, I called place order, it did go to the back office, get my different orders, do stuff with it, and then give me an aggregated result. Hey, you bought this. And that's like 42. You got the meaning of life, right? So let's see whether we can expose this as a get. OK. Oh, that's because we had to restart our Node.js server. That's nice. So this is actually a nice thing. 404 error cannot get. This is a nice way for express-to-express API. And that's basically our Explorer doing something. Something happened here. Let me restart this. OK, there it is. One of the reasons sometimes I face this issue of the services not coming up is something to do with DNS, localhost. Doesn't resolve properly. Let's do the get. We don't want to define all the models and schemas here, so let's just see what happens. So as you saw, we call the services multiple times. Believe it or not, the SOAP services, they were all called with different request sizes. And we got the different request sizes in our browser.
So what did the aggregation there of the parallel functions?
Sorry?
I'm trying to understand what aggregated the content when you use those parallel.
Right. So let me repeat the question. The question is, what aggregated the requests when the parallel calls were called? So what aggregated the request is this part of this code. So maybe I can go back to the slide, or I can go back here, because here it's, so you see this async.parallel, right? OK. So it takes a set of functions, right? So each one of them is a service call that we are making. So the first function that it takes, we just say function, and then we say, what's the service that we're going to call? The service that we're going to call is this, submit echo payload. What it does is it saves the result of this function into this variable called result, right? The same thing happens here. Because they are callback based, these variables are in closures. You see, the war result, it's in the closure. So this variable and this variable, they don't clash with each other. They're all in closures. This is also in the closure, closure. And then what happens is this magic happens. At the end of this parallel call, right? This is your entire parallel. At the end of it, there's a collector for all the results, and it's stuffed into this results array. Okay. Usually what you would want to do is this results array is the response, each response individually. That's what has happened here, right? So usually what you would want to do is you would want to massage that too. You want to do something that you send back one result back to your clients. You call so many things, you want to do one result back to clients, right? So you see, without writing all sorts of logic to handle the pipes, the asynchronous pipes, this happened asynchronously. That's why it is fast. It is working on one CPU, right? It's one thread. The CPU, whenever it is free, it can do work. So there's some network calls being made. It's free. It can take more load. And all of that goes into the asynchronous paradigm of Node. So it goes into this, calls this guy. There's a nice closure for us, stuffs the results back into this, and then calls our callback. And then the callback is basically the service that we are exposing, the client that we're exposing. I don't know whether that answers your question. Okay. Okay, so what else? Okay, let's go back to maybe my presentation here. So we saw how it's just the tip of the iceberg. V8 currently is working on, that is, Google is currently working on getting promises to be first-class citizens. Okay, so basically, in order to do this, there's something called Harmony. You start Node with Harmony, and then you get these promises that you don't have to write. You saw these number of callback closures that can sometimes get really hairy. So you don't have to write these callback closures too. You can write generators and yields. And as you play around along with it, you start to appreciate that you can actually see code, actually reason about code, which is written in an asynchronous manner. This is not always easy to do when you're writing function callbacks. So one other, I don't know why it good. Okay. So things to watch out. I mean, before we drink the Kool-Aid, the things to watch out is Node has its priorities. Okay, it's still in development phase. What I found sometimes is when you're especially binding it to, like, let's say, Oracle database, the newest versions of Oracle, maybe 11G, and sometimes you may just get suspend or vague errors. And you have to figure out what this means. So in this case, e-address info, for example, means some DNS error occurred. Okay? Or you might get like e-timed out. Event loop has, anyone who's worked with event loops, they know that it's got this stack trace that is so helpful because it's only 2 lines long. And in our Java world, we are used to having our stack trace to help us. And only then we kind of appreciate what's going on in the Java world. As you go into the event loop world, you really have to work with low-level programs like strace and dtrace. And dtrace is built on the D programming language. Okay. There's also the thing about the generational garbage collector, again, part of the V8 engine. Sometimes you have to dive deep into the libuv library. So before you get into production-ready code, you really have to get familiar, probably sleep with Node, so to speak, in order to use it. As long as you're doing simple things, right? As long as you're making use of the asynchronous nature of Node, you're not doing business logic. You're not doing a for loop inside Node. If you're doing a for loop, that's going to be synchronous. If you're doing for I is equal to 0, I is less than 100 million, that's going to be synchronous. It's not going to be an asynchronous thing. So as long as you're not doing that, you're using the right libraries. For example, in this demo, I did the transformation. One of the questions that can occur is, you're doing transformation, but transformation is like marshalling, unmarshalling, serialization, and deserialization. Isn't that synchronous? Yes, you could write it in a synchronous way. Question that pops up is, all of these things can be done in the Chrome browser too. So what is so great about doing it on the server side? So Node.js is basically server-side V8 engine, right? So the thing that is happening is you have to use the right libraries that actually go down. There are certain things that can never be made asynchronous. For example, if I'm going to do a fstat, that's not going to be asynchronous. That's going to be synchronous. There are no callbacks that I can make use of natively. But what Node does is it has a barrier that says go to the C level, right? And make use of the thread pools at the C level and simulate asynchronous calls here. You have to be aware of that sometimes. You have to probably sometimes go and dig deep into libuv, which is getting promoted. Right now, they are using libevent. But there are good things. And so the good things are you have generators and yield. It looks very promising because they support promise is now going to be supported natively. You're always forced to think about errors. And that's, in my opinion, it's a good thing. As opposed to making up a framework and then saying that the first thing is going to be an error. The default, if you're going to use libraries in Node, you're always going to have to use this kind of paradigm if you want it to be called by, let's say, the promise framework, which is already there in Node, or the promise library. So all of those libraries internally use this signature. With that, kind of like the Node libraries that we've used for reference, AMQP, and these are contributions, Node AMQP. There is Node async, elementary from Rackspace, great stuff. SOAP from, again, an open source library. You just have to tinker with it a little bit in order to solve your particular eccentric needs. Okay? You may have to dive deep into these. Loopback is great to show the demo. I use that. Swagger, lots of people are familiar with it. So, Durai, maybe you want to summarize?
Sure. Thanks, Monish. Isn't that pretty cool? I think it's, we could use some of these libraries and the tools along with some of the core framework like, RabbitMQ, Spring Integration, that runs our critical business, but then this adds some value on top of it. In summary, RabbitMQ for us really works well, scales to the number of connections we need, fast and secure, it's really good compared to a lot of other options. Binding for many languages, I think that is some of the key. Again, you may have a different need, but for us, that is one of the key needs. Works extremely well with all the languages we need to do because of some of the legacy code, as well as some of the new languages that is really getting popular. We want to be able to provide to our developers, adapt them, and that works well with RabbitMQ. Spring Integration allow the EIP patterns. I think the book was written by Greg, and it was awesome, and we started adapting that within ETrade. And Spring Integration is a natural fit, to kind of a blueprint of what EIP allows us to do. And we are able to do that, extend internally, also leverage some of the service activators that can be plugged into Spring Integration. In JVM orchestration, I think that's something really I'm fond of, doing things within JVM, because you're not going out of the process, trying to do some of the orchestrations within JVM that works very well within the Spring Integration. If you want to do something outside and to do some other orchestration, Node can be also a use if you want to do different. And for us, I think the async IO nature of making calls, because we have a lot of different services, we want to be able to fan out, make calls, leverage some of the parallel libraries Monish was showing you earlier, want to be able to make use of that. Also, the JavaScript as a language, it's just kind of very handy for needs like what we are able to achieve. I think that works well with the Node. So that's is the end of the talk. Here is our contact. Let's get connected. If you have any information, let us know. So that leads me to some Q&As. We can answer some of the questions if you have. And thanks, everyone. Yes.
So you're having, web calls is inherently synchronous, right?
Yeah.
So something has to negotiate the difference between the synchronous call coming in and the asynchronous nature of Rabbit. How does that work for you guys, and what problems do you have?
Yeah, so when the calls are made into our website, sometimes it's not just one service which is returning the data. It could be a bunch of services returning the data. So we have a library internally. We have a way to simulate the RPC nature for the client. But behind the scene, we're able to do an async call and optimize that and give the speed which is required for that pages. So we have a library within our framework that takes care of that and is simulating the RPC. For other examples, like if the client itself is outside, it's an external API or some other mobile client we're making call, that can go through something like what Node.js allows us to do. Yes?
So you mentioned two main reasons for adopting Node. One was that you using asynchronous call. Second one was protocol translation. Sort of, at least I got these two reasons. So I'm thinking you're using something like Tomcat, which is more conventional for translating HTTP, for addressing the needs of HTTP clients. If you get requests in Tomcat and just do the protocol translation in Tomcat, leave the synchronous or the asynchronous nature to the queuing mechanism, which anyway is supposed to be asynchronous.
Right.
So what is it, besides the fact that you guys love JavaScript and we all love JavaScript, besides that, why did you go to Node? That's where I'm not really getting the value proposition there.
Okay, so let me just repeat the question. So the question is, you have Tomcat. Everybody knows Tomcat. Everybody loves Tomcat. It's there in the market for a lot of years. And Tomcat can do HTTP to AMQP, yes, protocol transformation, right? If you use it as a protocol transformation layer. So that's the question. Why not use Tomcat? Why do you use Node? Everybody loves JavaScript. That's great. But why do you use Node when this can be done with Tomcat? So the question to ask here is, maybe I can probably divide it into one more layer. Why use Tomcat at all? Why not use Apache Web Server, right? So again, the reason why I'm asking you that is, if I use this Tomcat, where am I going to run it? I already have this Tomcat. So when I was bringing up these services were using Tomcat container also, and tell you that. They were not running like just Java and then Spring Integration and then just bring up the Spring Integration endpoints. They were running under a Tomcat container, right? So it actually, I'm trying to underline your point a little bit more, right? So they're actually running under a Tomcat container. They're bringing up all these things because Tomcat has these great shutdown hooks and stuff like that. But if you use Tomcat as the service container itself, it's running these services. It's running these multitude of services. You want those services to run separately. If something happens inside Tomcat, you don't want them to get affected by the calls. You want these deployments to be separate. You want them to be outside of Tomcat, right? That's one thing. You want this thing that is outside of Tomcat to be extremely lightweight. Okay, so Apache web servers are great. But Apache web servers, like at least till now, I haven't used it in an asynchronous manner. Maybe Nginx, okay? So I want an asynchronous web server, a sort of an asynchronous web server, but not as heavyweight as Tomcat. Tomcat has other uses. It's an application server. Whereas this one, you really want it to be lightweight. So my options would come down to Nginx, Apache with asynchronous support, okay, and maybe Node.js.
In addition, I think the language also plays a role when you do some of the work we do in aggregation. I think JavaScript plays better in the specific cases, so we were able to kind of make use of that rather than having a lot of objects created and handling with a lot of different marshalling and marshalling code and all that. So it works better in that nature. So Tomcat also now added async IO. Some other features are coming in Tomcat too. So there is definitely to watch out for. But we're kind of seeing which one fits in for the specific need, and then Node seems to work well compared to the other options.
Just one more thing. I don't want to drag this out too much. It's the part I'm not getting is the async at the Node level or the Apache level or the Tomcat level.
Mm-hmm.
We already have asynchronicity built in the queuing mechanism. We've got RabbitMQ, which is async. The whole queuing mechanism is inherently async.
Right.
So why do you need to have another async layer?
Okay, but you just mentioned that HTTP itself is stateless, right? HTTP is stateless, and it is request response. That means after a request, it's going to hang on to the request and then response. You have to wait for the response, right? So I have all this great queuing mechanism in the back end, fantastic. But my request is going to wait until I get the response back. I'm going to wait for the request, going to get the response back. Let's say I have 160 threads running. How many concurrent consumers can I now, at the same time, respond to? 160, if all of them are on these HTTP requests. What do I do if I have 161, 162, Facebook Day, IPO? What am I going to do, right? My queues are running fantastic. Okay, they are all asynchronous. But this is an RPC. This is going to wait till the response comes back. I want to hand over the request. As soon as it comes, I want to hand it over. And then my queuing system is great. I want to hand over. But HTTP, I want to handle in this smart way. So I want to use something asynchronous. The choice of asynchronicity, like what Durai is saying, we want to maximize our, what we use for asynchronous servers. Maybe Nginx, yes. Maybe Node, because Node, I can write these APIs now in JavaScript.
So in that case, don't you think you can use something like a subscriber model, like some kind of RX, where you take the request and then you give back saying, okay, I got the request from you. You do all the wiring, do the subscription, at the end give back the response. So
Okay.
From Tomcat, what happens is you get the request to your service layer, and then you say, okay, I got it, and then you give back the thread back to Tomcat.
Okay.
Now the process is done within the RX.
Right.
And then there's a subscriber listening at the end.
Right.
That responds back to Tomcat saying, here's the work done.
Right. So I'll just repeat what the question is. Why can't you use something like, you're talking about Netflix RX Java? Okay. So why can't you use something like Netflix RX Java, right? This has this asynchronous, I don't know how many people are familiar with RX Java, right? So it has this well, you have to really learn it. RxJava is not easy, but you really have to learn it. But it has this asynchronous nature that the moment you get a request, you have this bunch of subscribers, and these bunch of subscribers are, you can hand it over to one of them, and then it's waiting for another request to come in. That's the question, why are you not doing that? Not only that, I'll also announce that there are HTTP NIO connectors which are built in Tomcat, right? You can have NIO connectors in Tomcat. What we have found is whenever it comes to RxJava, whenever it comes to writing even anything complex, like complex paradigms, right? There is a screw up. You have to kind of handle that. And you want to reduce, in a big enterprise, you want to reduce that. Maybe write some sort of a decorative framework layer on top of it. So how do you minimize your losses, so to speak, right? How do you do it such that you don't have to worry about, unless you're doing something like maybe an exchange. Maybe it's you can go to the disruptor model, right? You've heard of LMAX disruptor? Anyone? Yeah, London, I think, market asset exchange, right? That's another model. But all of these are paradigms that you have to kind of teach, educate people how to write the consumers themselves. For example, even before all of this happened, all of this asynchronous world happened, there was always this thing called WS star. You could always start a consumer on the client side, and with the message, send a reply, who to reply to. And when you send a request with WS star, the WS star reply would tell it how to consume that message. But these are complex paradigms. We even found that why should we even maintain an RPC, right? The moment you tell people, oh, write this Java class like this so that you have this consumer which is waiting for the request after you published it. It's always an education. Minimize our education thing, and maybe people get excited about something like Node. So I mean, an answer that fits many things, probably not. If you want to do something really quick, something that is very critical, maybe you want to do it that layer. Here, you want to actually have people, we call it like application composers. They want to compose this API. They want to compose this UI. And they should be able to do this without knowing any of these details of how to call these concurrent clients and work with those concurrent clients. So we want to make this really simple. The short answer is make it simple.
Yeah.
I noticed that for counting a lot of your legacy services, your diagram shows it sort of wired up to RabbitMQ, but in a sense, don't you really have an ESP in the background? Is it like WSO2 ESP or Fuse or something like that?
There are some part of ESBs used, but I think we kind of try to leverage the architecture you saw earlier. That seems to be the way we try to run all the services, and then composition happens at more of an application tier, and it allows us to kind of reach out without having additional layers. So there are areas where we use ESBs, but there are many other areas we'd rather be able to call complete async service invocation.
One more question.
Someone that will come back to you.
User session in the Node app. OK. You probably don't want to maintain user sessions in the Node app if it is an API.
It's stateless, so.
Should be stateless. Oh, wait a minute. You're talking about end user. We're not there yet. But when we reach there, maybe we'll be able to answer your question, but we're not there yet. This is for internal clients. On some day, we would like to reach where the end user is, to rich client interfaces. This, when you saw the diagram, it was like internal clients which want to call through. Yeah. When you reach there, probably you'll have to do something with OAuth. And you'll have to pass tokens around. Yeah, I do have that, but it is not in production. So,
yeah.
Okay, so you have some services like from the demo that I saw, and is that where you're using the loopback
Yeah?
Well, it's pretty new, right? Like, what were you using before this?
So here's the question. So essentially, the question is, in the demo which I showed, I had this SOAP services, and then I was using something from Strong Loop called Loopback, and it has this SOAP connector, and it's fairly new. So the question is, what were you using before that? I was doing it myself. Essentially, me and a bunch of us, we basically wrote this, this SOAP connector, but I had to tweak, and I had to actually, I had to contribute to the GitHub, the AMQP, the SOAP library, Node SOAP library, because there were certain things that it wasn't doing correctly, the SOAP library itself. And so we had to do our own fork and use that. This is for the demo. I had to show something more professional. I couldn't show the dirty code. But thanks for the question.
Any other questions? Yes.
With all these various technologies on the Node.js level, you talked about REST, you talked about SOAP, you talked about ActivateMQ. How have you found it from your developers to the point of sustainment in the DevOps world, to be able to manage all these technologies, and how well has it been institutionalized within your organization?
It's a good question. So, that's some of the things I was kind of trying to convey earlier. We're trying to leverage as much as possible on the standards and how developers community generally adapts REST services or SOAP services. So some of the complexity we hide, that's what we try to do for our company, is to kind of bring this technology, bring all that, but at the same time, keep it somewhat simple for the development team to adapt. So for them, they can write regular services, and they can test it on Tomcat if they like, running it on the IDE and all that stuff. And then when it gets deployed, it gets into the system and it gets configured and run that within our systems. So that complexity kind of goes away when it gets into the actual development phase.
So do you guys have teams focused on certain technologies, or you guys have a bunch of developers that are a master of everything and an expert of none?
Can you repeat the question?
In the organization, the way we have is there are team focus on looking at the technologies, and that's what the architecture team does. And then the other application teams, they're more focused on implementing the business functions rather than looking into the hardcore technology. They do understand. There are architects and leads who are part of that team, know about the internals and all that, but their focus is not in how to kind of find out how to fix the technologies we are showing up here. Oh, okay. I wish we get the same thing here. Yes.
Wondering what libraries you're using for your C code to access the RabbitMQ.
C code to access RabbitMQ.
So we basically work off of an open library, and we made some changes for working with that library. It's if you send me an email, I can give you more details.
Same question, but for Python. Is there a standard library you're using for integration?
And same answer. Please send me an email. Yeah.
Yeah, some of the details. Yeah, we can send that to you.
Why do you use the
Let me repeat the question. Why do you use CXF instead of Spring WS? Okay, so I actually, not to pull any names here, but I actually had Mark Fisher look at Spring WS, and it was early 2012 when we were building this. Spring WS doesn't, in my opinion, have the kind of support, not even close to what CXF has. So as far as the interceptors are concerned, with serialization, you'll have to register your own, I think it is called OXML, XML serializer, and Out of the box, for example, with JAX-RS, with CXF, I can actually have those bindings done for me. There are 3 or 4 different bindings that come out of the box with CXF, right? So I'm more lazy. I don't have to do all this customization with what I'd had to do with WS. Okay, so the question is, are we thinking about moving from CXF to Spring WS? Well, maybe. We'll see.
You're always open to experiment, look into new options. So we'll look at it. If it fits, definitely. Okay. All right. Thanks, everyone, for coming.
Thank you.
Yeah. Hope this helps.